Welcome to our Virtual Science Labs webinar focused on our new flame test lesson. The goals of today's webinar are to introduce you to the Towson University Center for STEM Excellence distance learning resources, to take a deep dive into our virtual flame test lesson with our guest hosts, Allison Hapka, have small group discussions with colleagues, and to learn about your distance learning needs. I want to briefly introduce you to the variety of distance learning resources we have at the Center for STEM Excellence. First, we have virtual lessons, which are complete lessons that you can assign to your students to work on either asynchronously, or you can do part of the lesson synchronously during the time that you have them in your class and have them finish it up in their own time. We have virtual field trips. So from our SciTech Student Learning Lab, our SciTech instructors are hosting trips where your students can come and do many of the same labs that they used to do when they were in person at SciTech. We also have teacher demo kits, which are sort of one set of the Loner Lab materials for our Loner Lab kits that teachers can borrow to demo for their students from their homes or their schools. We have virtual science investigation videos, which is what this webinar is focused on, in which we have short videos that are not a complete lesson like our virtual lessons, but rather snippets that you can integrate into your already existing lessons. Finally, we have a Science Explorers Club, and this is for elementary students. We meet every Wednesday. And we have Science Shorts video series. And we have a virtual coffee house where we meet on the third Tuesdays of every month, which is a casual, informal gathering of educators to share resources and ideas. You can find out about all of these resources on our website, which is at towson.edu/CSE, and all of these resources are free. Before I turn this over to Allison, I wanted to give you a little bit of history about how this came about. So the Towson University created a virtual science investigation video of the common flame test that many chemistry teachers do with their students. This was at Allison's request through our custom science investigation video form. So any teacher can submit this form for us to actually do the activity and videotape it for them to use in their classroom. So on the left side of your screen, you can see the investigation video that Towson created. And again, it's not a complete lesson in that there's not sort of the introduction and the conclusion. It's just the heart, or the meat of it is the actual laboratory investigation. So then Allison created a more full lesson around this, and that's the icon that you can see on the right side of your screen, and she's going to work us through that lesson. So I'm going to turn this over to Allison.
Ready. So this is the change to present. This is the slideshow part that I put together after Mary's team did the videos, which were perfect, by the way. And when I do the flame test in chemistry, and I have regular chemistry, not honors chemistry or AP chemistry this year, so this is more of a practical chemistry class, I always do an investigation question up front. And for flame test, I say, does the cation or anion determine the color of the flame? So of course, everybody loves the flame test because it's colored fire. So first of all, they get to play with fire. And secondly, the fire is not the same color it usually is. So all of that makes for a very exciting lab. And it's usually the first time we learn how to use a Bunsen burner as well. So first we go through what an acid and a base are, because we have to talk about a salt, and they don't necessarily know what that is. So they have not written chemical equations yet. They kind of know acid base a little bit from biology, but this is a refresher, so they remember their vocab. And then this is a one slide that I didn't change. We have to update this to what we actually burned. But I have a bunch of household things that are just one particular type, and then a bunch of like stock chemicals and a whole bunch of chlorides, because when we're doing chlorides, we usually end up, when we do the flame test, we usually end up burning chlorides because that's what's around in the chem lab. And so still went over lab safety, even though it's virtual. I like Bitmoji classrooms. Case. There's my lab bench. We talked about that we gave a thank you to Towson. And then we went through some of the equipment. So also Towson made these beautiful NGSS posters as well. So if you're looking for a beautiful poster, they're on their website for download. So naturally, I put them in our Bitmoji classroom. I also put a periodic table up, and these are all links to various things as well. These are the reagents. We talk about goggles, so I have that on the bench there. This is the Bunsen burner that is not connected to gas, but none of the children noticed that, so it was okay. And I repeat the lab question. I repeat the directions, which is write a brief procedure of what we did and write a hypothesis before you look at the slides of what you think the answer to that question is. Or in this case, a lot of times they just said, I have no idea, because they didn't know what was coming up.
Allison, can I ask you, did you assign this completely asynchronously? Did you go over any of this together with your students? How did you do that?
So this part was synchronous. And then when we got to the individual ones, I did the first one together. And then I said, now you guys finish the slides and finish your write-up. So we were all kind of together there in the room, but I wasn't showing them each of the individual videos, is how I ran it. And then this was just an additional one because I had some more text and I didn't want it to be too small. Talking about using a nichrome wire in the flame. And I got some good questions about like, what is nichrome? And we talked about why we use nichrome wire, and the physical procedure you'll see in a second was very clean and good. So that really demonstrated. So then for each chemical, I have a little looped video here that just plays slowly on my network. So you can see the hand comes in, it burns it, and then the hand goes out. It's perfect. And nice clear colors. So I have there's one slide for each of the videos that they did. And it's the same kind of technique. So there's nothing distracting the kids, and they could all talk about what color it looked like to them. And then we have strontium, copper sulfate, pretty. I know everybody's already seen these, but it's nice because it's very clean burning. And then I gave them a table, and this is where they had to tell me what the cation and the anion was. Because we're in the beginning of the course, for sodium chloride, I literally wanted the word sodium in the cation column and chloride in the anion column. For honors, I would have asked them to put Na+ and Cl-. And later in the year, we can go back to this and say, well, let's practice on those compounds, because those are some good ones for them to be able to name. And then I had a couple go back to the original lab question to make sure that they got the point and figured out what the answer was. And we also, in the next class period, did atomic spectrum. And I'll show you where this fits in the whole process. And then 3 practical applications, which is super easy. We somehow end up with a lot of future firefighters in our school. A large population of my high school that become firefighters. So they kind of, whoever's in the class that is in fire science tends to lead that application part. So here is we use Schoology. And before they did that part, we did an article on what fire actually is. It's called How Fire Works. It's from the How Stuff Works website. And it goes through and it talks about changing form. It gives them the actual chemical compositions. My favorite picture of fire on the space shuttle or in microgravity. International Space Station, not space shuttle. The variables, how you affect it, things like that. So that's nice. That was like the intro. Then here's the flame chest. Then I did fireworks. So we did how fire works, and then fireworks as the application thing about how to get the colors. I leave this into spectral lines. So this is the CK12 animation on how electrons produce light, and it goes through neon lights and takes it through the electron. If you haven't used any of the CK12, just animations, they're kind of like simulations. It'll be like a little show and then like a lab part where they can play with it.
And Allison, does everybody know what CK12 is? Okay. Oh, Kate doesn't. So yeah, maybe just elaborate a little bit on what that resource is.
Yeah, so this is a company, organization, I think organization. I don't know that they're for profit. And they have a ton of science resources. And this is embedded in this is my LMS. So this is embedded right into it. And they have animations on everything. So if I hit launch, and then we wait.
Presumably it's free, or is that something that your county subscribes to?
No, it's free. It's free for everybody.
Right. We like that.
You can put together free textbooks as well from CK12. I use the other. So when you hit play, there's no actual sound. You're not missing anything because I didn't hit that button. It's like a that has like text and the picture. See, there's fireworks in the background, and you're supposed to notice the neon lights. And it's nicely timed. They go through a little bit of the history.
And presumably they have lessons like these on a lot of different topics. So you just embed those in your lessons. Fantastic.
Yeah.
Okay.
Yeah. So it goes through there and it goes through Bohr. I think we can fast forward. Nope, it only goes one speed. So it goes through there. It's kind of a nice way for them to take some simple notes on it. Then at the end, I have the high school POGIL chemistry book. So I did electron energy level and light, if you have that book, which is basically what happens inside the atom to make the spectral lines. And it does emission spectra and absorption spectra. And then I lead into electron configuration is kind of where that fit in the context. If that makes sense. Any questions? Yeah.
So I think definitely this is a time for you to ask Allison questions. And then I think also maybe comment on, do you teach this lesson to your students? How have you done it? Would you be able to use this? Or yeah, maybe some thoughts on that. Does it fit into what you need to do? Have you already done it this year?
I have to do it in 2 weeks.
Great. Okay. Do you think this might work for you?
Yeah, with my honors class, because of the language from the readings and things like that. I'd have to go through it very carefully for my regular classes, but my honors class, as is, I would be sending it to them, and I would do the same thing. I would do it either synchronously in class. We'd go through it, and then the questions they'd have to do asynchronous. Yeah. During intervention time in the afternoon, they would have to go to Google Classroom to do their asynchronous work from this lesson and then submit it in Google.
Okay. Anyone else?
So I can share. We actually do a fireworks unit. Our first unit is all on fireworks, and it goes, and we start with color and light spectrum. And so I did this probably the second week of school. And I did it fairly similar, not with the Bitmoji classroom because I'm not that tech savvy. But it was probably one of the lessons where I was really bummed that we weren't in the building, because I was like, I know the kids love this, but they seem to at least really enjoy seeing, I mean, who doesn't like seeing the fire change color? So they seem to like it.
And how did you use videos of the fireworks changing color as the example?
Yeah, I used just different videos that I could find of, this is very similarly to Allison. I just found individual videos of the flame color. I teach at a alternative school, so my students they need things very clear cut, and if I don't give that to them, they go a little off the wall. So it was definitely interesting, but very similar. I use Google Slides for everything, so the students can just write directly on it, and they really enjoy it because everything can be linked right there, and I can attach the videos right there, and they don't have to go to 10 different tabs or whatever.
Right, right. Yeah. Any other thoughts on this lesson? Yeah.
I'll share. We just finished doing this like 2 weeks, well, I guess last week. I teach IB Chem and then also honors chemistry. So for honors chemistry, like I got your video like right after we had done it. So I was kind of bummed that I didn't know that those beautiful little snapshots were available. For IB, I actually did a demo for them. I'm going into the building. So I did a demo and it worked okay. It was, I think, a little hard to see the colors through Google Meet. So I might put your flame colors on so they can go back. They should have turned in their lab report, but I know some of them haven't yet. So I could add that as a resource for them. But I do like how it's all in a package, how you started with even with the naming of the salt. Like I thought that was brilliant to start with teaching basically how does a salt form, just to get that information to them, even though it's not necessarily our topic yet. So that was great. I liked that a lot.
Excellent. Great. Now, are you on a semester system or are you doing year long? Like will you teach Chem again starting over next?
Oh, I'm year long.
Year long. Okay.
Yeah.
All right. So the ship has sailed for this year, but
yeah.
Okay. Excellent.
No, yeah, anytime we have a kid who's out for health reasons, though, this is a great plug-in for that kid. Because, maybe there's a field trip or an SAT or something on the day we do flame tests, unfortunately.
Yeah.
Yeah, the other part I was going to add in is what I did is I got the color flame candles from the grocery store, which burn in different colors. And in a dark room, it shows up okay on the webcam. So if you don't have a Bunsen burner and a wire and all that stuff, it's okay. They're not great, and there's only like six of them, but you do get a nice copper one and a white one that looks remarkably like barium to me. So I wouldn't put those on your kids' birthday candles, birthday cake.
Anyone else want to weigh in? Does anybody have this coming up? And you can put it in the chat too. And I think maybe some people are probably listening to this while they're cooking dinner. Totally fine.
So I'm planning on doing this next week. So this is actually perfect timing because I was trying to figure out how I was going to do this. So I think this will actually benefit me next week. So it's nice that it's all together already. So, yeah.
I also plan on doing the lab on Monday. I was also extremely sad that we weren't in the building to actually do this lab. This is one of the, funner labs that the kids get to actually participate in, and where we typically get a lot of engagement. And I was a little nervous as to how I would go about it, but when I saw those videos, I was just like, whew, a load lifted off my shoulders. And I really like how Allison embedded it within her Bitmoji lab. So I plan to do the same as well.
Fantastic. That's great. And I wonder, for the folks that have done this lesson, not this exact one, but did you get the same level of engagement from you? Obviously not the same level of engagement, but were they pretty interested in it? Or did it lose a lot because it was not in person?
I still had a decent amount of engagement, not nearly as much excitement as in person. Since someone said Bitmoji classroom, I had to share.
Oh, did you? Oh, is that your? Oh, there's your classroom. Right.
They're all like, why having pets is good for us, how plants clean the air. Yeah.
Yeah. So, how many of you raise your hand if you're not familiar with Bitmoji Classroom? Okay, you guys have got it. All right.
Okay.
Excellent. Fantastic. Well, I think one of the things that we were going to do was give you a brief, and I think we have some time. So maybe look into our next lesson. Allison, I can pull it up on my screen, and then, but you can. Do you want to talk about it?
I'll talk about it, and you bring it up because you have
Okay.
the recent copy.
Okay. So can you stop sharing, or I'll stop you sharing.
Okay. Good.
And I can make that happen. So we want the unknown substances one.
Yeah. This lesson was actually created for a teacher of forensics. But I think later in our year, I'm thinking like during the chemical reactions, like towards the end when we do acids and bases, this would be a good possibility. Because
are you seeing it now? It should be just like an
yeah.
slides that's not like playing. Does that make sense?
Yeah. So can you go to can you do present?
I can, yeah.
Okay.
Okay.
Yeah, there we go. So in each of the, I gotta figure out how to move around my. There we go. So there's a bunch of different substances which make more sense for forensics than they did for chemistry necessarily, but they are also common household substances. So this is the acetaminophen page.
And as a big overview, it's 8 known over-the-counter medications that we show these for. And then there's like a bunch of unknown slides that students can try to match up.
Can you make that one play?
It is playing. Oh, for me it is. Oh, I didn't do the right thing. So sorry. Okay, let me do this new share thing and
okay.
Hit. Oh, I did. I don't know why it's not showing for you guys. Oh, you know what? I'm going to put it in the chat as well so that you all can see it.
Oh, yeah, that's a good idea. So it's another one where it's a really clean presentation of the actual like manipulation of materials. There's a short little video for each one where the alterations are being made and like when they're putting the indicator in and the hydrochloric acid. And they have the setup with the mortar and pestle. And I also like the fact that everything like stayed in the same spot. So you have the clear labels, but then things kind of happen around it. Nothing moves around. So when you go to sample, it's still the same setup.
Is it playing now? Okay, great.
Yay.
And each one of these is about 2 to 3 minutes long, depending on how fast I moved. And I shouldn't necessarily have done the HCL, but I couldn't edit it out later. So it could maybe just be slightly sort of a distractor for the students. Like in real life, maybe everything you look at doesn't end up being relevant.
Right.
And there's actually an answer sheet that comes with this as well. So it tells you what you should be seeing. And to get that though, you have to email me because I didn't want to put it on the web because your kids are not stupid. And they're gonna, like, they might find it. I don't know.
They would find it.
Will they
Might
find
is
it if I
not the
just put it on
question.
the web for you to download?
Yeah, and then they have the pH scale right next to it. So.
And then we added this one in later, so it looks a little different on each one. But yeah.
But it goes through, so it has acetaminophen, which is a more complicated structure, but then it has Alka-Seltzer. We can write the formula for Alka-Seltzer.
Yeah.
Antacid? Probably.
Yeah, there's an
I
ant.
forgot what the active ingredient is and write that one. Aspirin, we do in AP chemistry. Then they've got other medicines like Excedrin migraine, ibuprofen, Hepcid AC. I'd have to look at the ingredient list for that one. Aspirin, tri-buffered aspirin. Talk about buffering.
Yeah, and so the buffered aspirin, let's see if we can find that. The interesting thing about that is that the pH changes over time.
Yeah.
Because of the buffer.
So there's really a lot going on in each one of the little slides. Like there's, even if you don't look at it as a huge project, even take in each one individually, talk about why medicines are coded.
Yeah.
You know, that's a huge benefit right there. So I saw a lot for our acid base unit, which I know is not for a while. So we've got plenty of time to play with it before then.
Yeah. Does anyone else see how that might be useful in what they're doing, or does it not quite fit?
It fits and it doesn't fit. I do a mini health unit with my 8th graders, and we do forensics. You know, they all become CSI people.
Yeah, yeah.
And this would be something with it. And the same thing in Science Olympiad. There is Crime Busters. So this would fit in as a training purpose for Crime Busters.
Great. And I think maybe you don't have to get into necessarily all of the chemistry behind it, but it could be a good observation inference lab. So, you know, students could just use it to say, how would you know if it's the same chemical or not, right? And then they have to just understand that they have to compare and provide evidence for why they think unknown K is one of those knowns. So another thing we were going to do was, I was going to break you up into small groups, but I think we have a small enough group here. I had some questions that I wanted to ask everyone, and let me see if I can pull up this Google sheet. No, that's not it. I guess what I would like to know is there anything that we can do to support all of you in any activities that we could create for you all, or I also want to talk about, here, I found it on my screen. There's the share screen button.
We could ask for single and double replacement labs.
No, just not for 8th graders.
Not for, no, for high school though.
Sorry, now I have all black. I'm not seeing anything on my computer. There we go. Okay.
We can still see you.
Okay, great. Let me try sharing this. Well, it's yeah. So let's do this. So these are some of the questions that I was going to ask you all. And hopefully, can you see a Google slide here that says group 1?
No.
Not yet.
No. Okay. Can you see anything on my screen?
Your name.
Okay. Well, I can just ask you the questions.
Yay, there it is. It
There.
just showed up.
Oh, it did? Oh, yeah.
Yeah.
Okay. Great.
Not very well in focus, though.
How's
Oh,
that?
got it. It comes in eventually.
Okay.
Okay.
I think my computer is just overloaded. So we talked a little bit about how you could use those things in your classroom. But what I would maybe in the next few minutes, what we could talk about is how have you been engaging your students in virtual labs? What are some of the things that you've been doing that has been working in order to get the students to be actively engaged and not just like receiving information from you? Are there any ways that you're allowing them to interact with each other? And I think I can.
I'll share. I
Okay,
think
great.
it's challenging because we only have 45 minutes twice a week with our students. So
Mhm.
I'm always weighing, is it better to present information or is it better to have them engage with the information? So I do a little bit of both, but breakout rooms work fairly well, although I never have enough time for them to actually like really think about and talk about the thing that I'm giving them to do. So that's frustrating. I feel like it's such a short time. I'm always trying to engage them, like asking them to type in the chat or asking them to respond. But again, it's not, there are certain kids that always will, and then certain kids that never do. So it's hard, but I think breakout rooms are good. And I think it does force them to actually talk to other people in the class. It's just time. It uses a ton of time and they really don't accomplish much content during that time.
Right. What county are you in?
Anne Arundel.
Anne Arundel, okay. Is everybody have that little time with their students? Synchronously. Wow, okay, yep.
Yeah. We
Yeah.
have 80 minutes a week.
Jasmine, okay.
So
Yeah.
we see our students every day, but it's for 45, it's only for 45 minutes. And by the time all of our students get in and get settled, most of the time it's just gone. It's 45 minutes is really not enough.
And I see them every other week and I see them for an hour. So I have A week and B week, like I have 2 separate curriculums, 7th grade and 8th grade.
Yeah. And how much time are they meant to be working alone, asynchronously between classes? Anytime or?
So I know in Baltimore County, we have 80 minutes with the kids for 4 days a week. 50 minutes of those are supposed to be synchronous, and then 30 of those are supposed to be asynchronous. But kind of, at least in my school, we have adapted that if the kids show up late, then they get asynchronous time taken away. That doesn't get taken away from our class time.
Right.
And in my school, they have they have the hour, 60 minutes synchronous for 5 days, you know, they're 7th graders, and then 5 days if they're 8th graders. And then they have an hour asynchronous at the end of the day called intervention.
Mhm.
Or no, when they go back to after intervention, they're with their homeroom, and then after that, they have an hour in Google Classroom working on their assignments. So it's really like 2 hours of, you know.
Right. So how do we feel that we're doing with engaging the students in the science and engineering practices, right? Are they getting some of the practices more than others? Like maybe analyzing and interpreting data, probably a lot of that.
Yeah, for sure.
Yeah.
Modeling is a lot harder to do in this scenario. I have finally gotten them trained to like just do it on paper and take a picture.
Right,
They were
right.
very reluctant to do that. And I was like, oh my God, you have a webcam.
Yeah,
Pull up your piece of paper. Let me see it. Yeah.
yeah. What about planning and carrying out investigations? How are they doing with that one? Kate?
Trickier because most of mine are pre-scripted, unfortunately.
Yeah.
Except in physics, because I'm using the Firefox phone app, and that uses the sensors built into your phone to collect data, and you can remote. I sacrificed my phone. Like we measured the acceleration of gravity using my phone. So they didn't have to drop their phone because our coordinator doesn't want us to have them.
Having them dropping their phone.
I was like, oh, whatever. So I dropped it onto a pillow. It was okay. But we measured acceleration of gravity, but I made them tell me what to do.
Okay, so that's how you
Yeah.
engage them in it. Yeah. Kate, what have you been doing?
So I'm currently a student intern, and so my mentor teacher has been she teaches a STEM Academy chemistry class. I'm not sure if that's Maryland statewide or not, but as part of their requirement, they have to do a science fair. And so they've been developing their science fair questions, and they can either choose to do a science project or an engineering project. And so they've been developing their questions and doing the background research, and there's been some check-in meetings that have been happening to make sure that they are on track with those things.
Yeah. So where are you going to school?
I'm at St. Mary's College of Maryland right now. I'm part of their master's program.
Fantastic. So I guess you can't really compare it to other years when it was in person, but how is that going this year? Are they following through on this? Has it been challenging?
From what I've seen, the students have been very ambitious with their ideas, and it seems like a lot of them are really excited about their projects and wanting to do a lot of really cool things. Some students are looking at different mask type of projects.
Oh, yeah.
Other students, they're building they're like automatic feeding systems for animals and such. So they're getting a lot of really good questions to come up with.
Fantastic. Excellent. All right. Any other thoughts on that? How we're engaging our students in the practices. All right. Well, I think we're... Oh, go ahead.
What was that app that you just mentioned?
Oh, let me type it in the chat so you can spell it.
Great.
Okay, perfect, thank you.
It's free. It's free, and if you put it up on YouTube, the dude who made it, I believe he's from Germany, is like just the ultimate nerd, super enthusiastic. He has great, it also, it'll connect to Arduino stuff for the one for Kate who said you were doing research stuff. And the Canadian universities, at least the ones down towards the Perimeter Institute, are using them exclusively this year. They've gone away from Pasco and Vernier, and they've replaced it with this phone app.
Because everybody has a smartphone.
Well, for the Canadian universities, they're requiring it for entry for college students.
Great.
I have a couple of Android, like $40 Android phones that don't have service that I have because I teach how to write phone apps too. So those will also be getting this app. So they'll be like the lab group phones.
Right.
It's
That's
fun that you put your phone in a salad spinner and then you turn it around and it can do like centripetal force and angular velocity and all kinds of cool stuff. I haven't figured out how to use it in chemistry yet, but I will. Give me time. It's coming. Yeah, it's a cool app. It seems to work super smoothly. The remote to your phone works great. Oh, the other thing that I just figured out yesterday that I was so excited about. I love Google Expeditions and we have Google Cardboard at school, but of course, even if we were in school, the children are not allowed to touch anything. You can actually remote between your phone and the computer and show augmented reality on your phone. Just make sure you clear the clutter on the floor where you're doing your augmented reality before you do that. So you don't have to like put away your extra pairs of shoes and stuff. But yeah, I was using that for chemistry for the nuclear parts. So radiation and there's a great one on Google Expeditions for hydrogen burning when we get to our chemical reaction unit.
And again, Google Expeditions is free, right? That's not something
Yeah.
your county's subscribing to. Awesome.
No, that's free. Google Expeditions is free. And the Chem 4D is also free. The one where you have to print out the cube and it's I don't know why they call it 4D. It's like there's some sort of image on the cube and then you hold your phone over it. And if you have the sodium and the chloride cube and you bring them close, first it shows just a block of sodium in the what looks like a paper folded cube, because that's what it is. And the chlorine looks like a little cloud of gas, the right size.
Wow.
Bring them together and it shows a little pile of salt and then the chemical formula.
And you print out this paper cube and you fold it up and then it becomes like that. That's amazing.
Yeah.
Before we go, maybe everybody, if you have, what's one favorite app or piece of technology that's been really useful in your teaching this year? Nearpod, yes.
Yeah.
Google Slides, I've used a lot of.
Oh yeah.
YouTube is my best friend along with PHET.
Mm-hmm.
Right. Okay, Christy, you said document cam. Yeah.
Oh yeah.
Absolutely. Yeah. And you know, you can
Love my
turn an
document
old
cam.
iPhone into a doc cam too, if you have an old one laying around. Right. Oh, Cami and Ed Puzzle. Yep.
Mm-hmm.
Great suggestions.
Yeah.
And I think the idea is finding something that works for you and for your students and maybe kind of sticking to that so they get to understand it and learn it. All right, well, I'm going to open this up for final questions. And if there are none, I really want to thank everyone for their time tonight. And please do, if there's any custom science investigations you want us to do for you, go to our website, super easy form that you just fill out what you want me to do, the dates you want it, and then I'll talk with you and we'll figure out the details of it. Yeah. Okay. Thank you, everybody. Good luck, Kate, with school. Is this,
Yeah.
You'll be out here next year, hopefully?